This is what we mean by model fit, or the goodness of fit of a given model. In layman's term, model fit means how appropriate is the model given the nature of the data. For instance, if all the variables in our model, they have a normal distribution and they are not very skewed, and they seem to be linear, and because of that, the ordinary linear regression model may be appropriate for the data. And if there are certain non-linear or curvilinear trends in some of the variables in our model, then maybe we should use logistic regression. And if the data in our model follows a time trend, we have the same measure for different time points, like cognitive functioning for time 1 to time 20, then maybe a time series type of regression or time series type of analysis may be more appropriate for the data. So, model fit, or the goodness of fit, means how appropriate is our proposed model given the nature of our data. And this is what we mean by an overfit model. An overfit model can happen when the model learns the irrelevant information, or the noise, or the errors, or other aspects of randomness in our dataset. And because of that, it's going to affect the fit for our training and testing datasets. We have an overfit model when the model fits the training data well, but it has a poor fit for the validation or the test dataset. And when we have a good fit for our training model, but a poor fit for our test or validation datasets, these can lead to low predictive accuracy. And this can in turn lead to high bias and low variance. And because of that, we cannot be too sure whether these associations or relationships actually exist in the true unknown population. And because of this high bias and low variance, we are uncertain about the goodness of fit, because we are not sure which is the true underlying pattern of the data. So, we can have an underfit model when we are being overly cautious, and because of that, we included too few relevant features or variables in our model. And we can also have an underfit model when we are being too cautious, and because of that, we over-regularize our model by using something like a lasso regression, by setting irrelevant variables or features to 0. When we do either one of these two things, these can over-penalize the loss function. You can think of the loss function as the difference between the predicted and the actual values. So, when we over-penalize the loss function, these can widen the gaps between actual and predicted values for our dependent variables. And these in turn can lead to low bias and high variance. And because of that, the extent of the bias and variance in our results may not be as accurate as we want them to be. And these can, in turn, led us to question the goodness of fit of our model because we are unsure about the true underlying pattern of the data. And underfitting a model can due to these reasons. When we try to prevent overfitting to the point that we are overly cautious, when we try to prevent having an overly complicated model to the point that we are being too careful, because of that, we included too few relevant features or variables in our model, or we overlook certain relevant variables or features in our model. All these things can lead to an underfit model.